Hey, welcome back. I'm Corey, and we're about to get started on day 2 of Advent of Code in Rust. In case you missed day 1, that video should be right over here in this corner, and the playlist of all of the videos should be right over here in this corner. Let's dive in. Okay, day 2, let's get going. Day 2 is rock, paper, scissors, so let's go get a new crate ready for that. It'll be cargo new. We're going to make a binary again. We're going to call it O2 rock, paper, scissors, and we're going to name it rock, paper, scissors. And let's add it to our cargo workspace. O2 rock, paper, scissors. Save that. Cargo run, binary. Can I just do the prefix? No, I gotta do rock, paper, scissors. Rock, paper, scissors. Okay, there we go. We got the rock, paper, scissors binary running. Let's just indent this over to there, make that look nicer. Okay. And we are ready to go for rock, paper, scissors. And actually, let's just CD into our day 2 here so that we can then just run cargo run on its own. Okay. The elves began to set up camp on the beach to decide whose tent gets to be closest to the snack storage. A giant rock, paper, scissors tournament is already in progress. It's a game between 2 players. Each game consists of many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using a hand shape. Then a winner for that round is selected. Rock beats scissors, scissors beats paper, paper beats rock. If a player chooses the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide, your puzzle input, that they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, C for scissors. The second column, suddenly the elf is called away to help with someone's tent. The second column, you reason, must be what you should play in response. X for rock, Y for paper, Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of the scores for each round. The score for a single round is the score of the shape you selected. 1 for rock, 2 for paper, and 3 for scissors, plus the score for the outcome of the round. 0 if you lost, 3 if the round was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide. AYBXCZ. This strategy guide predicts the following and predicts and recommends the following. In the first round, your opponent will choose rock and you should choose paper. This ends in a win for you with a score of 8. 2 because you chose paper and 6 because you won. In the second round, your opponent will choose paper, B, and you should choose rock. This ends in a loss for you with a score of 1. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3 equals 6. In this example, if you were to follow the strategy guide, you would get a total score of 15. What would your total score be if everything goes exactly according to your strategy guide? Okay, so our input, and actually let's take the example input, which is just this. Our input is going to be this number of rounds. So let's make this new file for our example input. And we will actually paste it in this time. Okay, so now we have our example input, and like before, actually we're just going to go ahead and make the part 1 function ahead of time, because I liked that from yesterday's. And this is going to return a number again. We'll do U64s like we did yesterday. And let's just have it return 0 for the moment. So then we can do let example input equals, we're going to do include string again like yesterday, just to include the thing in the binary, the example string. Then we don't have to deal with reading it at runtime or anything, just makes it a little easier. And then just to test it out, we'll just go and debug our example input. And we can cargo run this. And there we go. We can see our input and we can start parsing it. Okay, so again, everything in our input is broken up into individual lines, and each line is a round. So let's go and make a struct for a round. And a round has two things. It has opponent's move and your move. So opponent's move, and it has your move. And these are both gonna be, let's make a new thing for these. We'll call these moves. And let's make an enum for move. And actually, do we want one enum for move? Yeah, I think we're gonna do one for like one. It's gonna be rock, paper, scissors. So move it can either be rock, it can be paper, or it can be scissors. Awesome. Okay. So now each round is going to have a move for the opponent and a move for you, and move is going to be one of rock, paper, or scissors. Awesome. And I think we can start parsing things now. So let's go from our input. So let's do let rounds from our input. Let's do lines, which will split it on new lines so that each line gets its own string in the iterator here. And then let's map over this. So for each line, let's do round. This method doesn't exist yet, but it will in a second. So we're going to implement a parse method on our round and pass it in each line. And then we'll collect this to a vec of rounds. Okay. And then again, let's just keep returning 0 to return the right number here. There is no parse method, but I think we can go ahead and start implementing that. We'll impl for our round. We'll write a function called parse. It takes in an input string and returns a self. Okay, so then a round is going to be one line of our input. So it's going to be a move, space, and then the other move. So let's see, I think we would then want to split each line on the white space character on the space. So let's do that. Let's do let split equals input dot split, split. And we're going to split it on a space, and we're going to do it as just a character, not a string, because we learned last week that Rust Analyzer recommends that we do that. And then, so let's do let opponent move string equals split dot next. So calling next out of an iterator will get the next thing, in this case the first thing, since we hadn't called it yet. And then we can do let your move string equals split dot next dot unwrap. So now we have both of these pulled out nicely, but I think we actually want to parse them into our move enum as well. So let's go ahead and we're going to jump around and write an impl block for move here. It's also going to take a parse function with an input string, and it's going to return a self. This self is going to be the move enum. And here we're going to do, in move, we're just going to actually match on the characters. So we're going to say, we're going to match on the input. And if it's an A, then what is A? A is A for rock. A goes to, and this is move rock. B goes to move, I assume paper, I assume it's rock, paper, and then scissors. Rock, then B for paper, C for scissors. Perfect. C goes to move scissors. Can hear my cat Bobby in the background here. And then we're also going to map X to rock, Y to paper, and Z to scissors. So X will also go to move rock. And this is because they give us a different letter for if it's my move or the opponent's move. But I don't think we need that right now. So we're just going to collapse it back down to one enum here. And if we get anything else, let's panic with the string unknown move character. And that, I hope, should take the string input and return one of these enums for us. So actually, what we want to go, let's go back to our parse for the round. And we were pulling things out of the iterator manually into these lets, but I think we're going to do that a little differently. So let's get rid of these. Let's change this to be called moves. And we're going to split it on a space, and then we're going to map over it immediately. So this one is then, let's just call this I, because I don't want to think too much about what to name it. And we'll call parse on this input that we just got. And let's then just collect this. Actually, no, let's leave it as an iterator, because now let's do let opponent move equals moves dot next. So now we're going to pull things off of our iterator. The reason to do that is now we can parse them into the moves in all in one instead of having to do it multiple times. So that should be just a tiny bit easier for us. Next, dot unwrap. We're just unwrapping these because we're going to say that we always know there's going to be. I don't think we need error handling here at the moment. But then this, we can return a round, and opponent move is already the name of the variable, and so is your move, so we should just be able to do those. Oh, and it's opponent. I pluralized it here, but I don't think I want that, so it's opponent move and your move. There we go. I need to make this mutable so that we can actually call the things on it. And this is going to say that I can replace the closure with just calling move parse, so I don't need the closure there. It just cleans up the syntax a tiny bit. Okay, so now we should be able to... Oh, and let's do the same thing here. It wants me to replace the closure with just calling the thing. Then let's debug out our rounds. And then again, let's just keep returning 0. Actually, let's do the slightly nicer thing and return to do explicitly. So debug's mad because round, where's the error message? There we go. Round does not implement debug, but we know how to fix that from last time. So we go up to our round up here, and we can add a derive for debug. And then we have to add the same thing to, we have to add the same thing to our move enum here as well, so that it knows how to be debugged. And now we should be able to debug out our rounds here. And let's just call part 1 on our example input. And if we run our example, we should hopefully see, yep, so we panicked at not yet implemented for our to-do, but before that, we printed out our rounds with the opponent move and your move. Awesome. Okay. Let's clear our terminal down here. Oh no, terminal's having some issues. Let's just close out of it and make a new one. There we go. Okay. Let's open up where I was a second ago. Okay, there we go. CD into our O2. Sorry about that. We had some terminal issues, but we are good to go now. We can cargo run and see the rounds get printed out. Perfect. Okay, so now I think we need to go about scoring each round, probably. So there's two things that have scores. Each move has a score, which was the shape you selected. So you get 1 for rock, 2 for paper, and 3 for scissors. So let's implement that first on our move enum. It has a score that knows how to reference itself, and it's going to return a U64. That's the number type we've been using. And again, we're just going to match on self and convert backwards now from our things to numbers. So rock was a 1, move paper was a 2, and scissors was a 3. So that's rock, paper, scissors, 1, 2, 3. Rock, paper, scissors, 1, 2, 3. And then the outcome of the round. Okay, so that's the score for the specific move. And now let's write a score for the round. So function, let's write a score for the round. Again, it takes in a self, and it returns a U64. And actually, I think we're going to make 2 score functions. So let's make an outcome score. An outcome score is going to be the outcome of the round. So 0 if you lost, 3 if the round was a draw, and 6 if you won. So let's do the draw case first, I think. So if self.opponent move is equal to self.your move, if it's a draw, then let's return 3. And then let's just add this to do to get it to not be mad about returning. And then what is, oh, it doesn't think we can compare our moves together yet, but that we can again fix with another derive. We can, we're gonna derive debug, and we're also gonna do partial equal. Partial equal means that we're gonna compare these two with equality like this. So now we can compare that opponent move is equal to your move. If so, we're gonna return 3. So then the next thing I want to do is I want to say if you won. And how do I want to do that? I think what I want to do is I actually just want these to be orderable. No, not sure if that's gonna be right. So let's say, I think I want to write a method on move that takes in another move and decides if it's a win, loss, or draw. I think I like that. So let's do another function here called result that takes in self and other, which is a reference to another move, another self thing here. And then this is gonna return a, oh, this could actually, maybe this is where I just want to write outcome score. And this will just return a U64 then, so one of the scores from before. So I actually think I'm gonna go up and take this, and we're going to put it down here, except it's not going to be the same thing. So we're going to say if self equals other. So if they're the same, we're going to return our draw of 3. If, and then let's do a match. Actually, we might just want to do this whole thing as a big match arm. So let's do that instead. Let's do a match on the tuple of self and other. And so if we get a rock, move rock, and then a move. So we already got they're the same. So if it's paper, if you chose rock and the other person chose paper, that's a win for you. If you chose rock and the other person chose scissors, oh wait, no. If you chose rock and the other person chose paper, you lost. If you chose rock and the other person chose scissors, you won. And let's just fill out the rest of these. If you chose paper and someone chose rock, you win. If you choose paper and someone chooses scissors, you lose. And if you choose scissors and someone else chooses rock, you lose. And if you choose scissors and someone else chooses paper, you win. And then let's just organize this a little bit. Let's take all the win conditions at the top and the loss conditions at the bottom, just because I think that will look a little nicer. And will that format for me nicely if I add a... we have lots of closing brackets here that I didn't realize. Okay, so that closes my match, I think. But what is... There we go. But why is this still not giving me auto formatting? Where is my issue? Looks like I just have some things that aren't aligned nicely right now, but let's figure out where. My matches, those look rightish to me. If the other, where is my... This limiter might not be properly closed, but it looks pretty properly closed to me. Is it that we don't want that at the end? No, that should be fine. Okay, so let's organize this manually a bit. Maybe that'll help me see where the issue is. Is it that I need another one of these here? Yeah, okay, there we go. Oh, okay, so cool. I didn't match all of these. And I guess the other thing that I can do is I can just say if you get anything else, then it's a draw, because that's the only cases I didn't cover, and then I can actually do it all in the match. So all the win and loss conditions we covered, and we said everything else is just going to be a draw. Then our match is exhaustive and it covers all of the enum variants, so that's nice. Do I just want to write this out though? I think I want to be explicit and write this out. So if we want to do the three draws, so scissors, scissors, rock, rock, and paper, paper. Just felt like if we're doing the match, we're just going to be explicit with all of them. No great reason for that. Okay, there we go. So now we have our outcome score. And so outcome score of the round can now just be self dot your move dot outcome score with self dot opponent move. Like that. Okay, so now we have outcome score, and I think now we're ready to just write the actual score function for the round, which again is going to be a U64, and it's going to be, and actually, how does this work? This shape you selected and the outcome of the round. So we're going to do self.outcome score plus self.yourmove.score. So we're going to add the outcome score and the move, the score from your move, and get the total score. And then I think all we want to do is we want the sum of the round totals. And we're going to hope that it's 15 on our example input. So back down to our part 1 here. Part 1, I think, is going to be from our rounds. So let's do rounds.iter. And maybe we don't need this to be a vector, since we're just going to iterate on it again. But I'm not positive about that. So let's do, for a round, let's call the score, which is just the full score method, and then we're going to sum all of those up. And that should be our part 1 answer. So let's do let example part 1 answer equals this, and let's just debug it out this time. Example part 1 answer. And cargo run, if we see 15, we are hopefully good. There we go, 15. Example part 1 answer is 15. So now let's do my input. Get my puzzle input, copy it, make a new file here for my.input, paste it in. We actually are pasting it in this time. Let's copy all of this. Except it's not going to be example input, it's going to be my input, example, so this is my part 1 answer, goes from my input, and we're going to debug this out. There we go. Let's just do some reorganizing. Let's include these both up top, and then let's do both of those. Cargo run. Part 1 answer is still 15 because I didn't actually change this file to the my.input file. Let's try that again. 10404. 10404. There we go. Right answer. First gold star. Let's move on to part 2. But first, let's make a commit. Day 2, part 1 complete. We're just committing to the main branch, and VS Code is dutifully warning that I might not want to. Okay, and now let's read what part 2 is. The elf finishes helping with the tent and sneak backs over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated the same way, but now you need to figure out what shape to choose so the round ends as indicated. For example, above now goes like this. The first round, your opponent will choose rock, and you need the round to end in a draw. So you also choose rock. This gives you a score of 4. In the second round, your opponent will choose paper, and you choose rock, so you lose for a score of 1. In the third round, you will defeat your opponent's scissors with rock for a score of 1 plus 6 equals 7. Now that you've correctly decrypted the ultra top secret strategy guide, you would get a score of 12. Okay, so we're going to have to do our parsing a little differently. Following the elf's instructions for the second column, what would your total score be if everything goes exactly according to your strategy guide? Okay, so our parsing is going to be a bit different now. So in part 1, we were able to just call parse on the round, and it was going to parse everything, but I think we're going to have to rename some of these things a little bit to give us a different parse. So I think here we're going to rename round parse to be parse part 1, and hopefully that will have actually renamed it through so that we are calling, yep, parse part 1 here now. Awesome. And I think we're going to need a parse part 2, but first actually let's rename move parse to also parse part 1, because I think we're going to need a different thing there. Okay, so let's take another parse function. We're going to make a parse part 2 here. Okay, so we're going to still split the moves, but we're not going to map to parsing a move. So we're just going to do, I'm not even really like calling this moves now. Is this just a split? It's just the thing. Oh, except we could do it the renaming where it will help me out way. Let's just rename it to split. There we go. So opponent move, and then this is actually going to be like the end result. An end result is going to be the X, Y, or Z thing. So let's make another enum for the result of the game. It can be either a win, a loss, or a draw. Let's write an impl for our result. And then we're going to do a function called parse. It's going to take in an input string, and it's going to return to us one of our results. And we actually can take some of that from here. Well, the body of some of this is right. So X is a loss. So we don't need ABC. And X is going to go to a result of a loss. And then Y is a draw. Result draw. And then this one should be result win for Z, unknown result character. Awesome. Okay, so now we can parse our result enum and get this back. So then I think what I want to do is from move, I want to make another function called so what I want to do is we're going to do some method name, and it's going to take in a intended result, which is a result, and it's going to output a new self. And let's just write a comment here. This method takes in the intended result and returns the move you have to play to get the results in the round. Okay, so I think we now want to do a match here on... Do I want to make it a big match, or do I want to make it 2 small matches? I think we're going to do a big match. So we're going to match on self and intended result. So if we're going to want one of these. This has all of the cases. Well, they're different cases. So if the move is rock and we needed the result to end in a draw, then this is move rock. Let's just get rid of these and we'll copy paste this. Okay, so if move is a rock and you need to win, you would choose paper, because paper will beat rock. And then on the last one, if you need a rock and you need to lose, you would choose scissors, because scissors will lose to rock. Okay, and then let's do the next one. Let's add a new line between them. Feels like it might be nice. Except we're not gonna do rock anymore. Let's go to paper. Paper and paper. Okay, so if paper, this one then becomes paper. This is the matching one. If you want to win against paper, you pick scissors, and if you need to lose against paper, you choose rock. And we will do one more of these. We don't need two new lines here. We're gonna make these ones all be scissors. Scissors. Okay, so if you're gonna draw with scissors, oops. You're gonna draw. If you need to win against scissors, you're gonna choose rock. If you need to lose against scissors, you're gonna choose paper. Okay. Expected value self. I think I want that. Oh, I don't take in self here. That's why. Okay, there we go. And now what do I want to call it? Your move for result or something. It's not my favorite name, but that will work. Okay, so this is your move for to get the result. And now we have our parse part 2. We had a parse part 2 started. There we go, parse part 2. So opponent move and end result, except now let's actually parse these into the structs we need. So let's let opponent move, and I'm gonna shadow the variable and make it a new one without, so you don't have to make it mutable, we can just shadow it with a new one, which is pretty nice. So we can do move parse part 1, because we didn't change this here, so this can do the same parsing as before on opponent move. And then this will actually be a move struct now. And the end result, let's do is a result. And we parse that from the end result bit, because now our XYZ is an end result and not a move for part 2. And so then let's do let your move equals from the opponent move dot your move for result and end result. Because that should take our result and put it back to a move, and then our round can just use that move, and the scoring should be the same. So now all I think we should need to do is make a part 2 function like this. Part 2. And let's call parse part 2. And then we're just going to still sum up the score just like we did before. So then let's do example part 2 answer. That's example input on part 2. And let's debug that out in the same line just because we can. Cargo run. Example part 2 answer is 12, which I think is right. Yep, awesome. And let's then just do that for mine as well. Replace this with a 2, replace this with a 2, and add my part 2 answer. Run it, and 10334. There we go. Advent of Code Day 2 complete. Thank you for watching, and I hope you liked this. Again, you can check out the links to the other videos in the description below. And if you liked this, give me a like and a subscribe to get more videos as they get released. Thanks. Bye.